Good day everyone. So today we will tackle about metamorphism. Let's start. What comes in your mind when you hear the word metamorphism? Have you ever wondered what metamorphism is? How can heat and pressure change rocks to metamorphic rocks? And how can minerals change into metamorphic rocks? Good day everyone. Today, I will explain to you what really metamorphism is. Metamorphism. The word metamorphism is taken from the Greek word for change of form. Metamorphic rocks are derived from igneous or sedimentary rocks that have altered their form, recrystallized as a result of changes in their physical environment. Metamorphism is the process by which rocks change in composition, texture, or structure by extreme heat and pressure. The process of metamorphism does not melt the rock, but instead transform them into denser, more compact rocks. New minerals are created either by rearrangement of mineral components or by reaction with fluids that enter the rocks. There are factors that involve in metamorphism, which are the temperature and pressure. Temperature. It plays a crucial role in metamorphism. The heat affects the rock's chemical composition, mineralogy, and texture. For instance, during burial metamorphism, at a depth of about 8 to 15 kilometers from the surface of the crust, metamorphic reaction begins. The rocks adjust to the new temperature, causing their atoms and ions to recrystallize and form new arrangement, thereby creating new minerals assemblages. During recrystallization, new crystals grow larger than the crystals in the original rock. Next is pressure. Like temperature, it changes the composition and mineralogy and texture of rocks. Pressure is different in various tectonic settings like temperature. For instance, metamorphism in the subduction zone is characterized by high pressure metamorphism. In contrast, the collision zone between two continental crusts is marked by moderate pressure metamorphism. There are two types of pressure or stress, which are the vertical stress or confining pressure and directed or differential pressure. These two types of pressures, known also as stresses, exerts force on rocks causing changes. Vertical stress or confining pressure. It is the stress or pressure exerted on the rock by the weight of overlying materials such as burial metamorphism. This type of pressure is the same in all directions and makes the rocks to fracture or deform. Confining pressure is defined as the stress or pressure forced on a layer of soil or rock by the heaviness of the overlying substances. So kani si vertical stress or confining pressure is force ni siya sa layer sa rocks or soil tungod sa kabug-aton sa substances nga nasa ilang ibabaw. Next is directed or differential pressure. Is imposed by a force in a particular direction. Differential pressure is dominant at convergent boundaries where plates move toward each other and collide, thus exerting force, causing rocks to deform. Directed stress, sometimes called differential pressure, is also a force applied to an object, but the force is not the same in all directions. For example, when we squeeze a lemon, we are applying directed stress. When we stretch a rubber band, and we also applying directed stretch. The difference between confining pressure and direct directed pressure is confining pressure is general force applied equally in all directions, and directed pressures is force exerted in a particular direction. The difference lies in the directionality of the force of pressure or lack of thereof. Now, let's move on to foliation. It is a set of flat or wavy parallel cleavage planes produced by deformation under directed. Foliation in geology refers to repetitive layering in metamorphic rocks. Each layer can be as thin as a sheet of a paper or over a meter of a thickness. The word comes from the Latin "folium", means leaf, and refers to the sheet-like planar structure. Foliation, planar arrangement of structural or textural features in any rock types, but particularly the resulting from the alignment of constituent minerals gains of a metamorphic rocks of a general variety along straight or wavy planes. In this figure, the effect of compression due to pressure aligns the minerals as they recrystallize during metamorphism. The diagram on the left represents the minerals in shale, a sedimentary rock with bendings in direction shown. The diagram in the middle represents minerals in slate, a low-grade metamorphic rock from the original rock shale, with mica crystals orientated perpendicularly to the direction of the pressure. The minerals in higher grade metamorphic rocks seized with very evident foliation are represented by the diagram in the far right, which show larger bandings of minerals caused by even greater pressure. Next is hydrothermal fluids. It also plays a role in metamorphism. The dissolved minerals in the fluids reacts with the rocks, causing changes in chemical and mineral compositions, and sometimes completely replacing one mineral with another without changing the textures of the rocks. Hydrothermal metamorphism occurs when warm fluids significantly alter protolith rocks. This kind of metamorphism can affect the large areas and be part of the original metamorphism. It can be localized and part of the contact metamorphism. Oceanic hydrothermal fluids. Hydrothermal circulations occurs along the mid-ocean rigid, continuous volcanic chain stretching over about 60,000 kilometers when the seawater seeps through the fractured ocean crust. This type of metamorphism is also known as metasomatism, in which the alteration process is caused by fluids passing through the rocks and catalyzing chemical reaction. It can substantially alter the chemical composition of the rocks. This type of hydrothermal alteration is called metasomatism. Metamorphism caused by hydrothermal fluids also occur in mid-ocean rigid, where hot lava coming out the fissures reacts with mineral-rich ocean water. This causes serpentines to form through oxidation and hydration chemical reactions of peridotites, olivine-rich rocks of the base of the oceanic crust. This is also known as serpentination. Serpentination is the hydration of metamorphic transformation of ferromagnesian minerals such as olivine, just as I mentioned, and pyroxene in mafic and ultramafic rock to produce serpentinite mineral formed by serpentinization includes the serpentinine group. The serpentination happens when ultra-thick rocks and exposed to circulating aqueous fluids at temperature lower than 400 degrees Celsius. Now let's move on to the types of metamorphism. There are 4 types of metamorphism, which are the regional metamorphism, contact metamorphism, shock metamorphism, and burial metamorphism. Regional metamorphism forms foliated metamorphic rocks such as gneiss and seas due to high temperature and pressure imposed on large part of the crust. Most regional metamorphism occurs within the continent crust. Although rocks can be metamorphosed at depth in most areas deep below the mountains produced by the collision of 2 continental crusts is the area of greatest regional metamorphism. In general, the confining and directing pressure exerted by some tectonic forces onto rock formations cause new alignment of minerals or foliations during recrystallization. Next is contact metamorphism. It is another type of metamorphism which is prominent in areas where surrounding rocks are exposed to heat coming from magma intrusion within the layers of the rocks. Marbles, quartzite, and other granulonistic rocks with large visible crystals of minerals may be formed through contact metamorphism. In this picture, you can see the contact metamorphism process. Next is shock metamorphism. Including this metamorphism, which take place with the heat and shock waves from meteor or asteroids impact transform rocks immediately around the impact site. In this picture, you can see the shock metamorphism. The examples of these are the transformation of mineral graphite into ultra-high pressure polymorph diamond, and the conversion of quartz minerals into coesite under high shock pressure. Last but not least, burial metamorphism. It occurs at lower temperature and pressure, which transforms sedimentary rocks that had undergone diagenesis into low-grade metamorphic rocks through relatively low temperature and pressure. Partial alteration of mineralogy and texture may occur while other. This is an example of a burial metamorphism that can be found in the picture of the confining stress or pressure. In subduction zones between 2 converging plates, high pressure metamorphism occurs. Metamorphic rocks created through these processes are rarely found on Earth's surface as they were formed in such a great depth. Some metamorphic rocks formed through this type of metamorphism contain bits of microscopic diamonds, an indication the rock was formed with great pressure. An example of rock made through this type of metamorphism is the igloo site, which has transformed with pressure greater than 28 kbar at a depth of approximately above 80 km. And that's all. Thank you for listening.